One of the questions we had last week was about creating your quiz and using one of the formula questions in order to use that as a practice quiz, or in order to build a whole bunch of different questions. So I'm just going to run through that process quickly here. So what I did is logged into the LMS, selected quizzes, and again, when you're creating new questions, make sure you go to this little gear here and go to Manage Question Banks. And the idea here is you're creating question banks, and then you create quizzes from those question banks. I found this the hard way, that if you create the quizzes, it does create a question bank. It's just that everything's kind of jumbled up and it's not as organized as you might like. So what I did is I turned the 112, 115, those assignments are practice problems, homework. And what I didn't like about them was the students only got one chance at the question. If they didn't get it right, or if they did get it right, they didn't really know if it was right or wrong. So now with this system, they're able to get multiple tries at it. If they get it wrong, they know right away, and they can see what the answer was supposed to be, and hopefully help them figure out what the answer should be. So I just created a 112 Simple Machines Practice Problems group here. And let's pretend I need to add another question here. So up right hand corner, I'm just going to say add a question. And for this type, I use the multiple choice. And what I like to do here, as you can see, is I name the question. So whatever the simple machine was, let's say it was a lever arm. So maybe it was a first class lever. So when I go later to look at my simple machine questions, it's a lot easier for me to see which questions I need to grab. I'm going to choose a formula type question. So it changes a few things down here. And what I need to do is start typing out my question here. So if you have a lever of, let's say, 6 inches, and actually, let me reword that here. In a first class lever, you have, let's say, 20 pounds of effort force, and at a distance of 6 inches from the fulcrum, the resistance is located 12 inches from the fulcrum. What is the resistance force? Something to that effect. So with that type of question right now, every student will get the same question, the same answer. It's not really going to be unique for them. So what we can do is take out these numbers here, and I can put in variables. So what I do is I wrap that in brackets, and you can see when I click, once I put that in and I click somewhere, it adds the variable down below here. So I'm going to get rid of this one, and I'm going to put in, and you can really put whatever you want there in the brackets. So I usually, if I only have one or two, it's X, Y, Z, but you can put in A, B, C. If you want to put in DE for effort distance, or FR, whatever you need to put there will work. So now I have my 3 variables. I need to set up my variable ranges here. So if I have a first class lever, I need to make sure that the numbers all work out appropriately, that I don't end up getting inaccurate results here. So my X is the amount of effort force I'm applying. So let's say, 10 pounds to 100 pounds. If I want to get a decimal place, I can just choose, maybe I want 1 decimal place. And then I keep hitting recompute here just to kind of get an example of what it might put in there to hopefully see if it's the range. Effort distance here, so I only want this thing to be anywhere from, let's say, 3 inches to 6 inches. And I want it to be an even inch. So I'm not going to use any decimal places here. And then my resistance is located, depending on what I'm looking for here, I can get both above 1 for mechanical advantage, equal to 1 for mechanical advantage, or less than 1. So I can put in a range there. Maybe I'll put the same one in. And I can hit recompute here and see what the answers might be. Okay, so there's my variable ranges, and then what I need to do is go down here and put in the formula for how I would solve for this. So, be careful, make sure you're using the appropriate, it's solving appropriately. I like to use a lot of parentheses just to make sure everything's working out right here. So I need to take my effort distance times the effort, and then that would be equal to the resistance distance times the resistance. So in this case, I don't know the resistance, so when I rearrange my formula, it ends up looking something like this: X times Y divided by Z. And I can go back here and throw in lots of parentheses just to make sure everything solves right, even though that would still work out fine. And I can hit save. And then what I like to do, because quite often it comes out wrong, because you think the formula is solving properly, is I go through with paper and pencil and I make sure I solve it and I get the correct answer. So these are the numbers it's using, this is the answer it's getting, and I make sure that that's exactly what it should be getting. And you can put in, maybe I want a decimal place or two as far as my answer goes, so you can adjust that if you need to. So now you get your formula in. You checked it to make sure the formula is solving properly. Now you need to say, okay, how many possible solutions would you want here? So every time a student pulls up a question, it can come from a bank of 5, 10, 15, 20, 1,000 questions, or 1,000 possible combinations. I just throw 50 in here so that more than likely, if they're going to do the question over and over and over and over again, they're probably not going to get the same values. Here you can put in your allowable margin of error, and it all depends on the question type. If you're working in the millions, you might say, okay, it's allowable margin error of 1,000. If we're working in decimals, maybe you want it to be a little bit closer. You can also put in a percentage, so maybe I want it to be give or take 10% here. And then I just select generate. Comes up with 50 possible solutions. And then I typically will check the first couple just to make sure that that's the answer that I'm getting is correct. If it's not, then I need to go back and adjust this formula right here to make sure it is correct. And then a lot of times, especially for the practice, what I'm going to do is use these boxes to help the students out. So the green one is kind of like, yay, you did a great job, If you select that, if they got the correct answer, they would see this message, whatever you put there. I use the red one a little bit more often because, if they didn't get it correct, I'm going to put in here, remember to arrange the formula properly. And then I might give them the actual rearrangement of the formula so that they know how to do that. Then when they go back through, they can fix it. And then the last one, just kind of like a comment. Maybe it gives them, like, you could put in here, all right, now you've done this, go to this website and take a look at this video or something to that effect. And then you just hit update question, and that is good to go.